Hi, welcome to our second lecture on expected value for Math 135. So in this lecture, I'm going to talk a little bit about a more complicated example of how expected value works, show you the solution, how it all works together with the definition, and how you can put the pieces together. Okay? So you should have already watched the video on the definition of expected value. If you haven't, go back and watch that now. Okay? So we're going to look at another situation, another game, okay? So let me give you the rules of this game, which are more complicated than the one that we looked at in the previous example, okay? So in this example, we've got a bag of 20 marbles and with different colors, and basically you're going to win a certain amount if you pull out one yellow marble, and you're going to win more if you pull out both yellow marbles. There are two yellow marbles in the bag, okay? So let me show you the setup, then we'll talk about the probabilities, the rewards, and then we'll compute the expected value. Okay? So, in this situation, we have a bag of 20 marbles. Okay? 10 blue, 5 green, 3 red, and 2 yellow. Okay? So 10 blue, 5 green, 3 red, 2 yellow. Okay? And you're playing a game, and what you do is you pay $1 to play. You win $3 if you get exactly one yellow. Oh, I'm sorry. Let me back up. You pay $1 to play. You draw 2 marbles. Okay? So you're going to pay $1 to play. You draw 2 marbles. If one of them is yellow, you get $3 if exactly one of them is yellow. You win $10 if both are yellow. Okay? So when you're watching these videos, you should take notes because I'm going to have to erase a lot of this, right? And so you should write this down, make sure you've got this. So if you want to pause it and write this down, you absolutely can. But the rules are you pay $1 to play, draw 2 marbles out. You win $3 if you get exactly one yellow marble, and then you win $10 if both marbles are yellow. Okay? So let's think about these probabilities. Now the probabilities are harder to compute here, and that's what actually makes this a harder problem. The rewards aren't any more difficult to think about, but the probabilities are a little bit trickier. Okay? And we've got 3 different situations here. Okay? So what I'm going to do, I'm going to create a table just to kind of put this all down. So I've got my event. I'm going to have my probability. And my reward. Okay? So notice here there are 3 different events, and actually those lines are going to be too narrow, so let me redo that. Make sure I've got enough space for everything I need to do. That's going to be better. So 3 events. One is where you draw 2 yellow. One event where you draw 1 yellow. And one where you draw 0 yellow. Those are the 3 possible events. And we decide what these events are based on what the rewards are, right? Each of these has a different reward. If you draw 2 yellow, right, your reward is going to be that you win $10. But again, remember from the last lecture, your reward needs to be the total amount that you come out ahead, right? So you paid $1 to play in the first place, and so your reward is going to be 10 minus 1 equals $9. You win $10, but you paid $1 in the first place, and so you win $9 as your reward overall. Similarly, if you draw 1 yellow, you win $3 minus that 1 that you paid to play, so $2 overall. And if you draw 0 yellow, you win $0 minus 1, so negative $1 is your reward. Okay? So the rewards are the easy part. The probabilities, and of course we spent most of this chapter on this, so you know this already, the probabilities are more complicated. And in this situation, 2 of them are pretty easy to figure out, and the third one is super hard. Okay? And so I'm going to show you a strategy for when that happens, how you can kind of work with these probabilities. Because the advantage is, these are the only 3 things that can happen, right? So you could draw 2 yellow, 1 yellow, or 0 yellow. Those are the only 3 options. And so what we know is that these 3 probabilities have to add up to 1. Okay? So remember that all of the probabilities add up to 1. That's kind of the nice thing about probabilities, that if you've got all the events covered, they all add up to 1. So, drawing 2 yellow. Okay, so we did problems like this when we talked about probability. There are 20 marbles total. We draw 2 of them, and 2 of them are yellow. So the probability that the first marble is yellow is 2 out of 20. There are 2 yellow marbles out of 20 total. But the second marble, how many yellow marbles are left after you've drawn that first one? Since we know it was yellow, there's only 1 yellow marble left, right? We drew the first one out, now we've got 1 left. And how many marbles total are there left in the bag? Now there's 19, okay? And so remember, this gets you 1 out of 19 for the probability that that second marble is yellow, right? 1 yellow marble left out of 19 total marbles left, and we multiply them, okay? Remember, when we've got one choice and then another, we multiply them together to get the probability, okay? So 2 out of 20 times 1 out of 19. I already plugged this in my calculator before I started. You'll notice I'm learning a little bit about delivering online lectures. And so this probability comes out to 0.0053. So 0.5%. Not very likely, all things considered. And so you might, when your friend talked you into this game, you might say, oh, okay, this sounds like a good thing. But the probability of winning that $10 is actually pretty small. 0.0053. Okay? Now, your natural impulse in a problem like this might be to go next and say, okay, what's the probability of drawing 1 yellow? And unfortunately, this is a lot harder to answer because you have to think about, if you draw 1 yellow, is it the first one or the second one? Does that matter? Does it matter what the other one is? And the answer to all of these questions is yes. And it gets really complicated. So I'm going to skip over this one. And so if you find yourself thinking about one like this and you're like, oh, again, it's not going to work, right? Go to one that's easier. What's the probability of drawing 0 yellow marbles? Well, just like we did up here, when you start off for that first marble, there are 20 total, right? How many of them aren't yellow? Well, 2 of them are, so the other 18 are not. And so you've got a probability of 18 out of 20 that first marble is not yellow. What about the second marble? So the first marble you drew wasn't yellow. So how many non-yellow marbles are left? Well, there were 18 at first. We took 1 of them out. So there are 17 non-yellow marbles left. And then out of how many marbles? Well, we drew 1 out. So 17 out of 19 is the probability that second marble isn't yellow. Okay? So we get 18 out of 20 for the first marble not being yellow, 17 out of 19 for the second marble not being yellow. And when we multiply them together, we're going to get a probability of 0.8053. So 80.5% is the likelihood that you lose in this game. So again, your friend is looking more and more shady that they talked you into this game. Okay? And what we're going to do, now we've got, this one is 0.0053. This is 0.8053. If we take both of those numbers and subtract them from 1. So 1 minus 0.0053 minus 0.8053, right? So these three numbers have to add up to 1, whatever the probability of drawing one yellow is. And so if we subtract the other two numbers from 1, we're going to get the probability of the one yellow marble, okay? And that's going to come out to 0.1894, okay? So 0.0053 is the probability of drawing two yellow. 0.1894 is the probability of drawing one yellow, because it's the only probability left. And then 0.8053 is the probability of getting 0 yellow. Okay? So that's a way to get these more complicated probabilities. Remember, we called this the complement, the probability of something not happening. So if we don't draw 2 or 0, then we have to draw 1. Okay? So remember that rule as you're kind of working through this. Okay? So we've got our three probabilities. We've got our three rewards. To do expected value, we're going to multiply the probability times the reward and then add them all up. Okay? And so I'm going to do that. I'm going to leave this chart on the bottom. I'm going to erase the top. Okay? And so we're going to do probability times reward plus probability times reward plus probability times reward. So the expected value okay? So 0.0053, 0053 times the reward of 9 plus 0.1894 times the reward of 2, and then plus 0.8053 times the reward of -1. Okay, so 0.0053 times 9 plus 0.1894 times 2 plus 0.8053 times -1. Okay, so first event, second event, third event. We multiply them, then we add them up. If you put all that into your calculator, you're going to get -0.3738. -0.3788. Sorry. Misread it off of my notes. So -0.3788. So the expected value is roughly -38 cents. Okay? And so what that means is that if, say you spent an entire afternoon playing this game with your friend, paying $1 to play, and then winning either $3 or $10, depending on how many yellow marbles you got, right? Over the course of the day, on average, you would lose 38 cents a game. Okay? So your friend would gain 38 cents a game. So for them, the expected value would be positive. But you're losing 38 cents every single time you play, on average. Again, you might win $10 once, you might win $3 once, you might lose $1 a bunch, right? But on average, you're going to lose 38 cents every time you play. And that's what the expected value means. Okay? In our next video, we're going to go over a more practical example about thinking about how this is actually used in the business world. Obviously, you're not going to spend a lot of your job talking about drawing marbles out of a bag unless you, I don't know, go to marble drawing children's parties or something like that. So we're going to talk about kind of a more practical example of how this is used by insurance companies to think about risk. And that'll be our next lecture.